How you know something is a rational function is if you have a polynomial over a polynomial. So basically, you have an x in the top and you have an x in the bottom. Or you at least have an x in the bottom. Polynomial functions are always continuous. Meaning they start and they never stop. Like they go from left to right, negative infinity, positive infinity. They never stop. But a rational function is not, I'm going to underline that, not always continuous. My W looks weird. There we go. So there are three types of ways when you're looking at a graph or you're looking at an equation and you can tell where there's a discontinuity, which means that there's a break in the graph or there's an asymptote or a start and a stop. So the first way is a vertical asymptote. That's one way that you can have a discontinuity. Because if you have a vertical asymptote, part of the graph could be down here, part of the graph could be up here. There's a break between the two. The second way is if you have a hole, so holes. And then the third way is if the left and the right piece of the graph don't meet. And you'll see that a lot of times with piecewise functions. You can remember that. So we're just going to look at a graph. We're not even going to look at any equations yet. We're just going to look at the graph and see if we can identify if there are any holes or places where there's a discontinuity. So I'm going to scroll down to example 1. For what values of x is f of x not continuous? So is the function not continuous? What are some x values where there's a hole, an asymptote, or they don't meet? So -4, what's going on here? So there's a hole at x equals -4. And what was the other one that you guys said? X equals 3. What's going on there? It doesn't meet. It's actually an asymptote. So whenever they're shooting directly opposite of each other, like one's going all the way up and one's going all the way down, that's where an asymptote is. And 1.
But wait,
how is it not?
B1? Because if there's something under.
I don't think the other one meets the points.
So at x equals 3, we said there's a vertical asymptote. At x equals 1, they just don't meet.
Like, no,
Do you mean like their y values don't?
Right, exactly.
Okay.
Okay, next question. This is bringing in back a little bit of old stuff. What intervals is the function decreasing? Meaning like it's going down. Has a downward slope. Before we write anything down, let's just kind of circle it on our graph or highlight it. So where does it start from the left? From the very left at -5, is it going up? Up, 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 up. Where does it stop? -3. Then what starts happening? Starts going down. And it goes down until what? Good. Then it goes straight. Then at x equals 1, what starts happening? Starts going down. And it goes all the way to 2. And then it stops at that vertical asymptote. Then it picks back up. Or at, yeah, is that 2? Yes. Or is that 3? That's 3, sorry. And then what starts happening again? Picks back up at 3. Is it going down or up?
Down.
down. So we're going to have 3 intervals. And we can just put parentheses around all of them. So what's the first interval? -3, -1. Good. What's the second one? 3. And then what's the third one?
3,
Good.
infinity.
Infinity. Perfect. Goes on forever. Because it's like approaching 0, but it keeps getting smaller and smaller and smaller and smaller. Nice. Okay, now we're going to sketch the piecewise function. You guys remember that? Ooh, yeah. So what's usually my first step when I sketch a piecewise function? Like, what do these guys mean right here?
Boundaries.
Yeah, they're like my boundaries or my constraints. They're where one function starts and one ends. So I've got one at -2, and then I have one at +1. Then what's the next step? Usually whenever I'm doing this, how do I graph these? So how could I graph this y equals x?
Just 1 to 1.
So it's like up 1 over 1 from 0, but it's not defined as 0. Where does it start and stop?
The asymptote?
Mm-hmm. So it's everything to the left of -2 or everything to the right of -2? To the left of it. So what I normally do is I take my function and I plug in this value, and then I plot that point there. So the ordered pair would be -2, -2. And does that get an open or closed circle? Open, because it's just less than. And then I draw the rest of that graph to the left. So is it going to be going up 1 to the left 1, or is it going to be going down 1 into the down? Yeah.
Wait,
Because
how
it's
did
gonna
you
look
get
like that.
-2 and -2
I just plugged in -2 here.
to get the y?
Because like if I continue this, and sometimes people like to do this, where they like to draw the entire line. Whoops. They like to draw the entire line. Because this is y equals x, right? And then erase everything that's to the right.
Oh,
Okay, does that method work just as well as plugging in the -2?
Okay. Either one. Then the next one is -2. So if there's no x in it, then it's a what kind of line? Horizontal at -2. So does it get open or closed on the -2? Closed. So I'm just going to fill that in and then open. And then x squared minus 2, if we want to use the way of drawing the whole graph and then erasing, what does an x squared minus 2 look like? X squared is a what? A parabola. Is it going to be pointing up or down? Like a U or facing down? Up?
But it goes,
And then what is
but
it?
it goes down.
Goes down too. So here, up 1 over 1, points up like that. And then what parts do I erase?
The parts that are on the left of 1.
Left of 1. Okay. So close circles here, and then up.
So they're about to get a lot harder.
Okay, what values of x is it not continuous?
Wait, real quick. So if I was gonna plug in the 1 instead of drawing the parabola,
Mhm.
or then it would be
1 minus 2, so negative 1.
Okay.
Yeah.
Great.
Are we using all these today?
No. Okay, so then for what values is it not continuous? So there's either a vertical asymptote, which these are not asymptotes, these are just boundary lines. So I'm actually going to go back and erase these. So there's either vertical asymptote, a hole, or it doesn't meet.
There's 1 point as it shifts to 0.
There's 1 point it doesn't meet, and that's x equals what? 1. Perfect. We remember our parent function, 1 over x. Can you guys draw that? You guys remember? Where are the asymptotes?
Aren't those the x and y?
Negative 1.
0, that's like the x-axis and the y-axis. So there's dashed lines here, and then there's dashed lines here. And then where does the function go?
Like the
In quadrant 1 and 3, right?
So it's like top right,
bottom.
bottom left. Yeah. It looks like this. Remember we practiced drawing those because you guys wanted to make them like all curvy? We did that on the whiteboard. So as x gets close to 0 on the left, so this way, what's happening to the y value?
Stay the same.
Well, hold on.
When it kind of gets a little smaller, but like bigger.
Just going out.
The y value goes
Like
down.
it's going all the way to the left. Like as I'm getting closer to
Going to
0,
negative
it's going to negative infinity. Wait, I think I that's what I did. I highlighted the wrong thing. So it says as x gets very close to 0. So this right here.
Okay.
As x gets close to 0, I was reading it wrong. As x gets close to 0, so as it's getting closer to the origin, what's happening to my y?
It's getting further and further closer. Or just
It's going down all the way down, so y goes to negative infinity.
Yeah.
The mathematical way of writing this is as x goes, and the arrow just means goes, to 0 from the left side. So when you put a negative, because it's going to 0 in 2 places. You see how it's going to 0 from the left and from the right? There's another one up here that's from the right. So this is like saying 0,
Oh, I see.
0 to the left. We say y goes to negative infinity. So how could we write the mathematical way for the one to the right? As x goes to 0 from the right, what kind of sign do you think that would have? A plus sign. So we say 0 to the right. What's happening to y?
Y goes to infinity.
Pause infinity. Great. Okay, so we're going to just plug in a few values. Remember the parent function is y equals 1 over x. So when you see f of a number, what are you doing here?
Plugging it in.
You're plugging it in for x. So what's f of negative 3? Negative 1 over 3, or 1 over negative 3. Thank you. Okay, what about 1/2? So if I'm writing like 1 over 1/2, 2. 1 over 1/2. You flip and multiply. When you have like a fraction over a fraction, you take this.
I don't think I understand what we're doing. Where
We're
do we
just
get-
plugging in these numbers for x, for right here.
For which x?
1 over x.
There we go.
So if you've got a fraction over a fraction, you flip and multiply. So it becomes 1 times 2 over 1. Which is 2. What about 1 over 0?
0.
Nope. Zero's on the bottom.
Undefined.
Undefined. So what's happening, if you go back and I can't scroll up on this, but if you look at the graph you have drawn, what's happening at x equals 0? What's there? Nothing there. There's a vertical asymptote there. It's also where it's discontinuous because there's a vertical asymptote there. Okay, I want you to try graphing this one with your transformation knowledge. So let's talk about the two transformations we see here. What does the negative do? It flips it. So where it was in quadrant 1 and 3 is now 2 and 4. And then what does the x minus 2 do? It moves it right too. Perfect. So my new asymptote will be at 2. What about the horizontal one? Does it change? No, it stays the same. We didn't go up or down any. And then my graph now will be here and here. I probably need to draw this a little better. They're typically, if there's no shift or anything, there's a point that's diagonally 1 away from your center point. So our vertical asymptote we said is what?
2.
X equals 2. As x is going to 2, what does that minus or that negative sign mean? From the, good. Where's y going? So to the left, on the left side of 2, where's my y going? Positive or negative infinity? Positive. And then the right of 2, where's my y going? Negative infinity.
Like, how do you know where your y is going?
What it's doing, so this
If
is,
it's pointing up or down.
yeah.
Okay.
So to the left it's pointing up, and then to the right it's pointing down.
Ms. McKinley, you
Uh-huh.
said that discontinuities, occur at a vertical asymptote. Why don't they occur at a horizontal asymptote?
Because a discontinuity is your domain.
Okay.
So we're reading it from left to right.
Okay.
Oh,
These are already drawn for you. I made them, put them on there for you, so you're welcome for them.
what about
We didn't have to go in the
example
calculator and do
five?
it.
What do you do?
Did you get example?
Oh, we didn't do those?
Good sheet drawn out of it.
Oh, we didn't. Okay. So based on what we saw in our vertical asymptote, it was at 2, which we noticed was from our shift left or right. What would our vertical asymptotes be for part A?
-4.
Oh, that's my highlighter. X equals -4. What about B?
X equals 5.
Good. And X equals? Awesome.
Not that bad.
Okay. No, it's not bad.
Yeah.
So here's where we're going. We're not there yet. We're not ready for it, but we're getting there. We're close. So what do you notice about these functions compared to the ones that we just drew? Maybe like what the equation looks like.
It's like
There's 2 x's. There's one on the top and on the bottom.
Also x squared.
There's also an x squared. We haven't really seen that before. Right now, all I want to do is look at the graph and decide where the vertical asymptote is. So we're not ready to actually graph these yet. But let's look at it. So part A, it's where a vertical asymptote is where one's shooting in one direction and the other's shooting in the other direction.
2.
Looks like 2. That's what I would say. What about B? There's two of them.
Would it be 3?
3 and negative 3? There is, but we're not going to deal with those yet. That's for tomorrow. Mhm. And wait, is that because of Y, Graham?
Like when you factor out the
Whoa.
That's what I thought in my head.
Oh
too.
my gosh. I'm going to cry right now. Might be the proudest that I've ever been of y'all.
Really?
Tears are forming in my eyes.
We all
You
get
actually
hundreds from
gonna
that last
cry?
test.
No,
Yeah,
but that was
we need it.
really, that was just very heartfelt and touching.
Wow. Remember that
It's like
one
those
time we
teacher
all
moments.
failed the factoring quiz?
No.
With the
That was
thing.
hilarious.
That was
I
the
forgot
hardest
about
thing
that.
ever. Everyone was like, no, it's so easy. And now it's just like
less than
factoring.
100.
Okay, what about this one?
That's gonna be at
0.5.
0.5 or negative 0.5?
Can we retake the test over factoring?
No. But there's a
We
lot
write
of...
it as a fraction, like x equals negative.
Okay, what fraction do we think this one would be? 2.5 or 5 over 2. Yeah. Well, you know, I wanted you to discover this after this point, but you guys have already figured it out.
We're too smart.
You're too smart for these notes. So how do they compare to the denominators? What am I doing to the denominators? So I set the denominator equal to 0, and that becomes my vertical asymptote. Y'all are dominating this. So we're not looking at the numerator or anything right now. We're just looking at the denominator and factoring it and setting it equal to 0. So you wanted your factoring test back, David? This is it. There's so much factoring in this unit. You get to redeem yourself. This is the time for you to
He
shine.
is so excited.
This is the time for you to shine. So A, I'm just looking at the denominator here. How would I factor this guy? Let's let David do it.
2x
Mm-hmm.
plus 3.
Mm-hmm.
2x minus 3.
Boom.
Alright, that's enough for me.
That was
I'll take another
amazing.
test grade, honey.
So my vertical asymptotes are what? And you can write it as plus minus when it's something like this.
Plus or minus 3 over 2.
Amazing. Okay, I want you to try B by yourself. Give you some
4x plus 7.
x plus 4, x minus 7.
No, x minus 4x plus 7.
Oh. I heard y'all wrong.
Yeah, you're not allowed to mess up after all the stuff you put us through.
I didn't put you through nothing.
What do you mean you didn't?
So x equals what?
The only thing that's
4
not in this
and
class is
x
my grade.
equals
Negative 7.
negative 7.
Get it?
Okay, try C. Spread your wings and fly.
Wait.
Oh, okay.
Think I'm fast with this?
So you pull the x out, and then
Yeah,
it's
actually is what I got.
2x plus what?
Plus 5 and then x minus 4.
And so when we set all of those equal to 0, we get x equals
Negative 5 over 2.
negative 5 over 2, 4, and what else? 0, because of this guy. We cannot forget about him.
Wait, but wouldn't that just be 1? What is it?
It's x equals 0.
X equals 0.
So then if that equals 0 and it's
So we're setting-
everything else, wouldn't every x equal 0?
No, we're setting all of, so if I said x equals 0, that would mean the denominator equals 0. If I said x equals negative 5 over 2, that would mean the whole denominator would equal 0. And if I said x equals 4, if you plug all three of those values in, you would get into this original one right here. You would get 0 on the bottom. That's what that's doing. That's why we factor it. Okay, let's look at the next one. Now we're going to factor the top and the bottom.
What do we do?
Factor top, factor bottom. Just factor top and factor bottom right now.
Oh, well, I did.
X plus 2 on the bottom.
X plus 3, x minus 1 on the top. On the bottom, x plus
2.
x minus 1. Now, Does something cancel?
Yeah.
Is that killing a puppy?
No.
No,
What? It's in parentheses.
because it's in parentheses. So you don't kill a puppy if it's in parentheses. So we changed it into factored form. Now, based on our rule, what would we expect at x equals 1 and x equals -2? What would we expect to happen? That there would be what? That there would be a vertical asymptote,
So that's what they meant.
but it got canceled, so I'm confused about that. But we'll just put it there because we're not sure yet.
Wait, are you confused about it, or are you using it to teach us? I'm so confused.
I'm confused. I don't know. I'm learning here, right?
That's not a good sign.
We're all learning together here.
That's not how teaching works.
Do we have
Yeah, it's
Do
just
we have a pop quiz any day?
I don't
Or
know.
are all of our
Don't put
quizzes
that in her
scheduled?
mind.
Like, you can't give us a pop quiz.
Please
Like,
give us a pop quiz. At
Okay,
least
we're
let
gonna
us
put this
know.
as a placeholder. I'm just gonna circle it right here, and we're gonna move on and try another example.
That she doesn't know what happened.
Because I don't know what happens yet, so we're gonna just have to figure it out. Okay, let's try factoring this one. Let's try factoring this guy. Oh, is this the same one? It is the same one. Okay, that's why I did that. So we've got x plus 2, x plus 3, x minus 1, x plus 2, x minus 1. And we've canceled these out. So this is what we had in factored form. Now, what do you notice at x equals 1?
Oh,
There's a hole.
That's tiny.
That's tiny.
just
Because
fill
it's
it
not
back
zoomed
It's
in.
not that big of a deal.
The one below is zoomed in. The one below it is zoomed in. There's a little hole.
What?
So there is a hole at x equals 1. Is there a vertical asymptote there?
Nope.
No. There's only a vertical asymptote where? So there's a vertical asymptote here, but there's a hole here. Hole, no VA. No vertical asymptote, just a hole. So the next version is zoomed in, just to give you a better look. What happens at x equals 1, there's a hole. Now if I plug in x equals 1 to the graph, or into the function, so f of 1, let's go ahead and do that. Plug in 1. We've got 1 squared plus 2 times 1 minus 3 over, I'm just plugging it into the original. 1 squared plus 1 minus 2. Zero over 0, right? Now let's try plugging it in after we've canceled. So what's left over after we've canceled the x minus 1s? Now let's try plugging in 1 here. What do you get? 4 over 3, right? And what is this y value?
Lost.
4 over 3 is like 1 1/3.
Yeah, that was.
Four. Well, this is counting by 0.5.
Oh, okay.
Yeah.
I was confused. Yeah, 4 over 3. Say it's 4 over 3. It's 4 over 3.
This is like 1.5. This is about 4 over 3. So after you have canceled, then you can plug in that x value, and then you'll get your y. But if you plug it in before you have canceled, you'll end up getting 0 over 0. That's why there's a hole there. So if something cancels from the top and the bottom, like if factors cancel, you actually have holes at that value. So vertical asymptote, just to kind of recap. Yes, Avery? It's not there anymore. What did you want? What part did you want?
I didn't get part B.
A vertical asymptote at x equals -2. Okay, so just to recap,
Where did the x plus Where did the x plus 2 part come from?
That's how we did when we factored it.
Vertical asymptotes are when you set what equal to 0? Denominator equal to 0. And holes are when what happens?
When it doesn't have anything.
When factors cross out. Holes should be written as ordered pairs. So that's where I got the 1 comma 4 over 3 from. So in my step-by-step process, when I ask you to answer one of these, step 1 you want to factor. Step 2 you want to cross out. And then step 3, set denominator equal to 0. After that. So don't set the denominator equal to 0 until you've crossed out your holes. Okay, so we're going to just go through 3 quick examples just to get you started for your homework. We're going to do the first one together, and then I'll let you do the last 2
With your help.
with your shoulder partner. Okay, so I cannot factor the bottom on part A, but I can factor the top. So what could I do? How could I factor the top on part A?
X plus 3x minus 1.
How do you? This is our genius. How do you do it
And
so
then
fast?
x minus 1.
3 minus 1 is 2.
Davey,
Does
you're so
anything get
dumb.
canceled here? Those get canceled. So I'm just left with y equals x plus 3. That looks pretty familiar, right? So would I have any vertical asymptotes here? Because there is no denominator. It's like 1. It's like x plus 3 over 1. So there is no vertical asymptote. But there is a hole at 1 comma what? How did you get 4?
Yeah. Plug it into the x plus 3.
So I plug in 1 plus 3 here. I plug in my hole
Whatever crosses out, you plug it back in.
with what's left over.
Okay, so you crossed out the x minus 1, so you're plugging in a 1 to the x plus 3.
Mhm.
So say it was x minus 2.
I'm plugging in a 2. Mhm.
So you don't, do I pay attention to the sign at all?
Well, no, it
Yeah.
goes-
It's like you're setting this equal to 0.
That's all I need.
Uh-huh. And even if you forget, like, okay, which one do I plug it into, the original or the one that's crossed out? When you plug it into the original, what are you going to end up getting?
the 0.
0 over 0. So when you see that, there should be a big red light that's like, that is not right. 0 over 0 is not right. So let me try plugging it into the one that's already simplified and already crossed out. So my final answer would be these 3 things right here. I would want your final equation, I would want your vertical asymptote, and then I would want what your whole ordered pair is. Okay, try part B. So here, like I said, it's okay not to have a hole. There's no hole. So if you factor and you feel like you're supposed to get something that cancels out, you're not wrong. But something doesn't have to cancel out every time, and it's not going to. Then for vertical asymptotes, I set each parenthesis equal to 0 on the denominator. So my asymptotes are x equals what and what?
-4.
Those are my vertical asymptotes. And you can just put VA. Okay, try the last one. C. How did we factor the top?
X minus 1, x minus 3.
This 1, x minus 3. How did we factor the bottom?
Plus 2, x minus 3.
So x plus 2, x minus 3. Does anything cancel? X minus 3. So that means that there is a hole
At 3.
at 3, comma,
4.
And I plug in 3, and you get 4 over 5. You don't have to show your work plugging that in. You can just eyeball it.
Forgot to plug that in. And then is there a vertical?
And then there's a vertical asymptote. I set the denominator equal to 0. There's only one thing left over, which is the x plus 2. So it's at x equals negative 2.
Wait, why not at x equals -1? Because
Because you're just setting the denominator equal to 0. You don't do anything with the top.
so that x plus 1 has nothing to do with the.
We're not doing anything with that yet. We will learn later that we'll use that in some capacity, but not right now. Okay, now for the last thing, it says sketch the graph of the function from part A without using a calculator. Now, what is left over in part A? What's the only thing left over? X plus 3. And what is that? Just a straight line. So try graphing it.
Wait.
Try graphing x plus 3. Oops, that's a highlight. Uh-huh. Algebra 1, people. Algebra 1, x plus 3.
You start at 3 and then 1 over 1.
Uh-huh.
Yeah, that's what I was
Wait,
So, since you start at every x value has to be 3 less than the y value. So you just start at 0, 3, and then just go 1 to 1.
We got that? What am I forgetting here?
Oh,
What am I doing? Forgot my hole.
What the whole?
Look at him. That's kind of weird. Let me try this again. It's kind of a big hole. It's at 1, 4.
Oh. Okay, guys. Alright, let's start on our homework. That way I can have this done. Come on, everyone. It'll be fun.
Perfect.